Hey guys, today is a really short lesson, so I thought it would be just as easy to do it this way. We'll plan on meeting on Wednesday morning for Wednesday's lesson, just have a check-in before the long weekend. So today is 11:3 on the number E. All right. The number E is a special irrational number. It is an odd phenomenon that they've found in nature to happen over and over. You'll see different problems in today's assignment, for example, that use the number E in it. There's some different growth that uses E, different kinds of money that use E. So that's what the number E is. It is a number. It's the weirdest thing about it. Okay. What it is defined as is the sum of the infinite series 1 plus 1 over 1 plus 1 over 1 times 2. Okay, you can see working its way down, keeps going on forever. All right. If we were to approximate it to 3 decimals, it would be 2.718. So another special irrational number that this reminds us of is pi. Just like pi, this one doesn't have an end. It goes on forever, never has a pattern, but is used in different odd ways. So E and pi actually have a lot in common, right? The function y equals e to the x is one of the most important exponential functions. All right, here's kind of a sketch of it. Just like all of our other exponential functions, it's going to cross the y-axis at 0, 1. All right. If you want to look on page 712 in your book, or you could graph it on a calculator to see a better example, but this is pretty close sketch. Okay. Exponential growth and decay, it can be modeled using an equation with E. Okay, so this is kind of important. This is our equation using E. N equals N0 e to the kt. This, remember, this is E the number. This is a number in here. Do not confuse that with a variable. N is the final amount, NO is the initial amount, K is a constant number, T is time, and E is a number. It is on your calculator. Do not approximate 2.718 for E. Use the E button on your calculator. It's different than your E letters, so carefully look for it. All right, example. Refer to the application on page 712. So let me read that to you. This is about medicine and relating it to E. Swiss entomologist Dr. Paul Mueller was awarded the Nobel Prize in Medicine in 1948 for his work with the pesticide DDT. Dr. Mueller discovered that DDT is effective against insects that destroy agricultural crops, mosquitoes that transmit malaria and yellow fever, as well as lice that carries typhus. It was later discovered that DDT presented a risk to humans. Effective January 1st, 1973, the United States Environmental Protection Agency banned all uses of DDT. More than 1.0 times 10 to the 10 kilograms of DDT had been used in the U.S. before that ban. How much will remain in the environment in 2010? Okay, so here is our problem. Okay. With our information, assume that there was 1.0 times 10 to the 9th kilograms of DDT in the environment in 1973, and let's see, and that for DDT, the K equals this. Okay, write a function to model the amount of DDT remaining in their environment. use E. So we're going to use this equation over here. So N is going to equal our original amount will be 1 times 10 to the 9th. We're going to do E. They gave us a K, so negative 0.0211 T. That would be our equation. Okay. Because this is a 1, we could simplify this equation to 10 to the 9th times E to the negative T, right? All right, next question says, find the amount of DDT that will be in the environment in 2010. All right, so we're gonna, in our equation here, we're gonna need to substitute time. How we're gonna find time is we're gonna take 2010, we're going to subtract from that 1973, okay. And that's going to get us that our T is going to equal 37 years. All right, now we need to just plug that up into our equation right here. So we'll have not a y, n equals 10 to the 9th, e to the negative 0.0211 times 37. Okay, plug this into your calculator using the number E. This is a calculator button. Okay. So you're going to come out with an answer that is approximately, okay, or you could just plug this part in your calculator. That's what this problem did. Saying that it's approximately 10 to the 9th times 0.45808 52394. So what it's saying is that if there was 1 times 10 to the 9th kilograms of DDT in the environment in 1973, then there is about, we're going to move this decimal over 1, which is going to make this number become 1 smaller because this becomes 1 bigger. So we're going to have about 4.6 times 10 to the 8th kilograms of DDT in 2010. Okay. And then the next thing says use a calculator to verify the answer in part B. So take this equation right here. You're going to plug y equals 10 to the 9th times E, and y equals 37, and we're going to find out when those meet. And that should equal this. All right, so try that out on your calculator. All right, page 2. We're almost done. One more problem. Like the fastest notes ever. Okay, so when we're talking about interest with E, okay, we talked about how money can accrue interest last week. Money can accrue interest daily, yearly, monthly, semi-annually, And what the letter E tells us is that we can also accrue interest continuously. So it's constantly accruing. When you accrue it continuously, you use a different equation. Okay. This equation I like to call PERT. Okay. So our final amount is going to be the principal, initial amount. I'm going to also say slash principal, because usually in money we call it principal. This is just the number E. So once again, this is a number. Okay. To the rate times time. So that's interest compounded continuously. Okay. All right. So let's do a problem. It says, compare the balance after 25 years of a $10,000 investment earning 6.75% interest compounded semi-annually and continuously. Okay, so for semi-annually, we're going to need to use our equation from the other day. So let's find the difference in the two equations. Nice thing about PERT is that there's a lot less pieces to plug in. All right, so over here, this is going to be our semi-annual one. So our number of times it's going to be compounded is going to be 2. Okay. So our principal, our beginning amount was $10,000. Our rate, remember that has to be a decimal, so 0.0675 divided by 2 times 2 times 25. Okay. You can go ahead and plug this in your calculator. You could make this just off the top of your head to make your plugging easier. 50. Okay. So that amount is going to be $52,574.62. Okay. All right, so we're going to use PERT now, our compounding continuously. Our principal is 10,000. Remember, E is a number. Our rate is going to be the same, 0.0675. Our time is 25 years. Plug that into a calculator. I'll put it down here with the other one. Okay. That's going to equal 54,059.49. So as you can tell, over that 25 years, compounding continuously actually gained us about $1,500, which, I mean, I would take $1,500. I think you guys would too. All right. So we can find out exactly how much the difference of the two is by subtracting them. Okay. So this gives us an amount. The difference between the two is going to be $1,484.87. So about $1,500, which is pretty awesome. You have a problem you're going to work on tonight that's going to work on compounding in all different forms. I think it does annually, semi-annually, quarterly, monthly, daily, continuously. So you can kind of see the growth over that much time and how that actually changes it, which is pretty cool to see. Kind of good for future knowledge. So, all right, done. Homework. Page 714, number 1 through 2, 6 through 9, and 11. This is going to be due to me on Wednesday. We're going to have a call Wednesday morning at 9 o'clock to go over 11-4, just so I can meet and check in with you before the long weekend. I'll also send the information out to you in email form so you have it. If you have any questions, as always, please feel free to send me an email and I'd be happy to hop on a call with you. Have fun with this short assignment. Bye.